So here we have a beautiful geometric representation of the torsion tensor. Um, and essentially, we take this vector from P to Q, we parallel transport it in this direction v rho, okay, which is with transport with respect to the Riemannian connection, okay, and ensuring that essentially the covariant derivative is 0 of the vector field as it's transported along this from P to R. And then we could also just view the value of the vector field u at R. These are going to be two different measurements. Now the difference between them is the directional derivative of the vector field u in this direction v here, okay? So the difference between the value of the vector field and its at R and the value of a vector which is infinitesimally close. Remember, these 2 points are infinitesimally close. If I parallel transport this vector along v, then the difference between this and the true value of the vector field is the directional derivative of the vector field in the direction v. And then we can define this same process for the direction u here and the directional derivative of the vector field v along the direction u. And now the first thing is that we now are comparing, so we now look at the Lie derivative, which is this commutator of vector fields. And really what's happening here is we're looking at the difference between u sub r and v sub q here, okay? But this is problematic because we're basically comparing tangent spaces of our manifold at two different points, right? So everything, let me draw some arrows in red here. So the arrows in red that I've just drawn as part of this diagram, these arrows don't make physical sense because the points R and Q, here and here, are at different points of the manifold, so their tangent spaces are actually different. So how do we compare these sets of two vectors for each point R? At R I have two different vectors, and at Q I have two different vectors. Now I want to compare them to get the Lie derivative, which I'm going to put it in here in yellow here, and I'm also going to compare these other two vectors to get the torsion, okay? And so how do I compare them? Well, as I've written here, I don't fully know. So if I'm just learning this subject right now, so if you have a better explanation, if you are more of an expert in this topic, please let me know. But my current understanding is that we're actually comparing these vectors by pulling them back along the respective flows. So this vector is going to induce some flow, okay, some geodesic flow, and we can imagine that actually there's a geodesic connecting P and R, okay? And similarly, there's a geodesic connecting P and Q, okay? And these geodesics are parameterized by some flow. That flow is due to the vector field V, okay? And now the idea is that we're actually going to pull back the vectors in these tangent spaces. We're going to pull them back by this geodesic flow map and pull them both back to P so that we have now four vectors at the tangent space P. Namely, we just pull back these two different tangent spaces at R and Q along the respective flows. And that way we can compare actually the vectors, and let's say that I've colored yellow here, we can compare these vectors to the vectors which are at the tangent space of Q, which I'll color in green here, okay? So by pulling back along the respective flows of the vector fields, we can make these comparisons and complete this geometric diagram here, okay? So this piece of the diagram is something that I've been spending a lot of time thinking about, and I'm going to keep thinking about until I understand it, but I don't fully understand it yet, to be completely honest. This is where I'm at in my current reading course. I'm doing a reading course in differential geometry, and I'm kind of a little bit stuck here between this geometric interpretation of the torsion tensor and also the geometric interpretation of the Riemann curvature tensor. I'm a little bit stuck as to how to understand these constructions geometrically as opposed to just understanding their formulas. And the theorems shown about those formulas algebraically. I'm searching for a geometric intuition behind these Riemann, and torsion tensors. And so any input, any advice that you have would be greatly appreciated. Thanks.